Our urban forests are known to provide some mitigation of the impacts of climate change, including the urban heat island effect. However, the same forests are subject to a number of stressors that can have a negative impact on their viability. So to ensure that our urban forests can provide a continuous supply of benefits to society and the broader environment, they must be resilient and capable of minimizing the impact of many stressors. Before I go further, I must emphasize that most of the urban forest is on private property and not under the jurisdiction of the city. Please keep this in mind for the rest of the following discussion. The urban heat island benefits or functions that is most relevant to the theme of this panel discussion is microclimate amelioration, or in other words, a reduction in the so-called urban heat island. But our urban forests have a long list of functions or benefits that they provide in addition to the microclimate amelioration. Time doesn't permit a detailed discussion of these benefits here, but the take-home message is that these functions are not mutually exclusive. So an extensive, equitable, and resilient urban forest will contribute to all these benefits, including the mitigation of the urban heat island. By extensive, I mean a forest that has a spatially well-distributed canopy. And by equitable, I mean the urban forest benefits are accessible to all citizens. I won't go into these two here, but we'll focus on the resiliency of the urban forest. Before we go on, let's consider very briefly how these benefits are related to the structure of the urban forest. Each of the benefits in our list can be shown to be related either directly or indirectly to the leaf area of the tree in question, or the forest as a whole. Leaf area is simply the total area of the leaf surface area of all the leaves on the tree, in part of the forest or for the forest as a whole. Fortunately, leaf area can be estimated from tree measurements such as crown width, crown height, and crown density, and of course, the species of the tree. As you can imagine, leaf area increases with tree size, but leaf area increases exponentially with tree size. So the take-home message here is that big trees are important. This means that we should be establishing trees of a species that have the genetic potential to become large, grow them in sites that can support that potential, and to ensure that they remain structurally sound and healthy for as long as possible. Of course, we can't plant large stature trees on every site, but we should be trying to avoid planting small stature trees like crabapples or Irish-wick lilacs on sites that could support larger stature trees like bur oak, for example. As I mentioned before, trees and the urban forest as a whole are subject to many stressors that can have an impact on the forest's ability to provide benefits. And in some cases, trees can damage property or cause injury. Some of the most dramatic stress can be caused by wind or ice storms. Prolonged droughts and flooding can also weaken trees and even cause mortality. Diseases can also weaken and potentially kill trees. Ottawa residents are familiar with the ravages of emerald ash borer. Asian longhorn beetle is another introduced species that attacks maples and other hardwoods. It's been found in Toronto, but an aggressive eradication program appears to be working. But it is well established in the United States. Gray infrastructure above and below ground compete for space with tree roots and crowns, and the construction process can be particularly destructive. These are just a few examples of the stressors that have an impact on our urban forests and their ability to provide the long list of functions or benefits, including helping to mitigate the effects of climate change. When we think of resilience, we must consider the resilience of the individual tree as well as the whole forest. For example, an individual tree will be more resilient to wind or ice damage if it's been properly pruned throughout its life. Species diversity is a very important component of the structure of the forest that can increase the resilience of that forest in the face of pests and disease. Now let's consider two of the most important components of urban forest resilience. Resistance is the first line of defense against the stressor and focuses on the before crisis activities to increase the ability of the tree or forest to withstand the impact of the particular stressor. For example, injecting ash trees with the systemic insecticide triazine before they become infested with emerald ash borer, or establishing an urban forest with high species diversity so that the loss of one species has a reduced impact on the entire forest. These would both be referred to as the resistance component of resilience. On the other hand, recovery is, as the name implies, is the ability of a tree or the forest to recover from the impacts of a stressor and restore the tree or forest's ability to function as it was before the stress. One example is the ability of most hardwoods to recover from defoliation by certain insects like the spongy moth, provided of course that the tree was healthy before the infestation and that repeated infestation doesn't occur. It's important to note that most conifers don't fare so well with defoliation, so they don't do well in terms of recovery. Now let's think about some characteristics of trees and the urban forest that contribute to resistance and recovery. Species diversity is one of the most important components of resiliency and as has already been mentioned, a resilient urban forest won't have all its eggs in one or a few species baskets, so to speak. Of course, a diverse urban forest has other benefits like adding to a greater diversity of insects and animals, as well as visual diversity. Many neighborhoods have an urban forest with trees of generally all the same age. This is simply a product of how these neighborhoods were originally developed. Just the aging of the forest could result in the loss of a large proportion of the larger trees around the same time. A continuous and regular effort to introduce new plantings to the forest is the best way to transition from an uneven aged forest to an all-aged one. Generally, an urban forest comprised of healthy trees with good physical structure will be a healthier urban forest. Trees that have been well maintained throughout their life will be less likely to lose limbs or completely fail in major wind or ice events. Trees that are healthy will be have greater ability to resist or recover from droughts, floods, or pest attacks. To have trees with good structure and health, remember the old adage of the right tree in the right place. Trees must have good conditions below and above ground, and regular monitoring is important. The importance of an adequate growing environment above and below ground can't be overstated. Again, this means adequate space for the mature size of the tree, adequate soil volume, and soil of good quality, including aeration, drainage, fertility, and freedom from pollutants such as salt. While we might be happy to just let a wildland forest do its own thing, so to speak, this is less practical in most of the urban forest. The resiliency component mentioned above must be supported by tree and urban forest stewardship. This begins long before any planting activity begins by understanding what the long-term goals of the planting are, carefully selecting sites and planting stock, establishing the trees using best management practices, and most importantly, monitoring and maintaining the trees throughout their life. So, what are some actions that can be taken to enhance the resiliency of our trees in urban forests? To understand how resilient your urban forest is and what steps can be taken to improve resiliency, you must become aware of the state of the urban forest on your own property, in your neighborhood, and in the city as a whole. One approach to gaining this awareness and to take action is through a program called Neighborwoods, which includes the inventory protocols mentioned earlier, a set of criteria and indicators of sustainability at the neighborhood level, and a template to guide the development and implementation of a neighborhood urban forest stewardship plan. Currently, there are 4 neighborhoods in Ottawa involved in the Neighborwoods program. Centertown is one of these. Let's look at just a few of the outputs from the Centertown urban forest so far. This is a map of part of that inventory. There's a rule of thumb that no species should represent more than 10% of the trees in the urban forest, no genus more than 20%, and no family more than 30%. Like most Eastern Canadian communities, Norway maple is overrepresented at 20% in the part of Centertown that have been surveyed so far. The maple genus represents over 50% of the trees in the survey so far. Remember also that Norway maple is an invasive. The take-home message is, if you're thinking of tree planting in Centertown, lay off the maples for a while. It's difficult to age trees in the urban forest since homeowners don't take lightly to people drilling into their tree to remove a core to count the annual rings. Neighborwoods uses tree stem diameter relative to the maximum diameter for the tree species at maturity. As you can see, the data for Centertown suggests that the area surveyed so far are a little short on small or young trees, and the number of older trees with large relative diameters are somewhat more abundant than desirable. The neighborhood survey approach guides volunteers through a detailed assessment of tree condition using a standard set of 17 criteria. These are combined to provide a detailed description of the health and structure of the tree and are also summarized for the forest as a whole. Here you can see that the area surveyed so far, 88% of the trees have no major sign of health or structural defects. This is encouraging. However, at the same time, we can see that 7% have major structural defects and 3% have major structural and health defects. The Neighborwoods Inventory Report also shows a very detailed assessment of every tree in the inventory that can be used to guide tree maintenance procedures. Planting a tree is important, but remember that a tree in the forest that it belongs to can't be resilient on its own in the urban environment. Community groups can play an important role in improving urban forest resilience. In fact, it's my opinion that given that most of the urban forest is on private property, a truly resilient urban forest can only be achieved through community action. Thanks for your time.